Hello, my friends. Welcome back to the last lesson of the 15 days TCS NQT Cracker series. From tomorrow, we are going to start with 7 days rapid revision test series. So I hope you are excited for that. We have just 1 week left for TCS NQT, and it's time for give everything for the revision so that you ace the TCS NQT. So there are a few announcements I would like to make before I start today's class. My first announcement is that TCS has announced that they are not going to take any more in-center examination this month or this May series. They have requested everybody that they will take the examination from the home only, and I think you all have received the mails regarding to it. So all the best for the examination. So today we are going to finish the rest of the coding topic that we are left with. Today we are going to do the rest of the topics of linked list. In the last class we did what do we understand by linked list and how we can implement a simple linked list in C. Yes, in the last class, we did two functions where we added a linked list or added a node at the end of the linked list. And we did another function where we added a node at the beginning of the linked list. These were the two functions that we did. We ran those functions and checked the results. Apart from that, we also studied how a linked list can be represented, what is a linked list, all those questions we read about this thing. So these are the important topics when it comes to your interview or when it comes to your coding topic. So in this class today, we are going to finish up the topic by discussing the deletion part and the searching part of a linked list. So before I start with the deletion part, let us discuss the strategy just like we discussed in the previous class. So let us imagine that we have a linked list. This linked list contains only of three nodes. We have an header and then we have a node. We have another node and then we have another node. We have in total of three nodes. And we know that the linked list, every node in the linked list contains the memory address of the next node. So let us imagine that the memory address of this node is 100. Memory address of this node is 200 and memory address of this node is 300. So the first node is going to have the memory address of the second node. So the value will be 200 here, value will be 300 here, and 300 is going to store null. That signifies that this is the last node in the linked list. So as a result, this node will be connected or linked with this node. This node will be connected to this node. This is your header, or as in this program, I have named it as start. This contains the memory address of the first node. So this will contain 100 and this will be connected to the first node. So apart from this memory addresses, every node also contains a data part. In this particular example, the data part is in character. So this will contain A, this will contain B, and this will contain C. These are the data part. So our first challenge of today's class is to delete a particular node from the beginning of a linked list. So now let us discuss this strategy, or what should be our way of deleting a particular node from the beginning of the linked list. We know that this particular start thing points towards the first node of the linked list. So as to delete this first node, it would be beneficial that if this particular node points towards this second node instead of this first node. If this particular header points towards the second node, then this node is officially deleted, as because we are going to start traversal from the first of the linked list. header of the linked list. So let us write, or let us start with our deletion function. The name of the function is void add beginning. Sorry, this will be del big. We are deleting a node from the first of the linked list, or we are deleting the initial node of the linked list. As because we are deleting, we don't require any argument to be passed through this function. So this function is not going to return anything. This function requires no argument. The only thing that this function requires, or the thing that function does, is that it deletes the first element of the linked list. So let us start with our first statement. First, we are going to write node start temp equal to start. So temp variable is going to store the memory address of the header or head of the linked list. So in this particular case, the value of temp will be 100. So let us make a note of this one. So the value of temp will be 100. This is the value of temp. Now in the next statement, we are going to write start is equal to start dot next. So the value of temp is start, and then we are writing start equal to start next. So the value of start was 100 and start next. So the value that is stored in the next part of 100 is 200. So this particular value, instead of 100, this will become 200. And as because this has become 200, this connection will be severed, and then this mm, header will be connected to the second node of the linked list. So now we have successfully disconnected the connection to the first node, and we have connected it to the second node. So once we have done with this, so what we are going to do is that we are going to delete this memory address because we no longer need it. So as to delete this part, what we should do, we should write free temp. And what is the value for temp? The value for temp is 100. So if the value for temp is 100, so this is going to delete the elements that are present in the 100 memory address. So as a result, this node is deleted. That means an element or a node is deleted from the first of the linked list. So that was our function to delete a node from the start of the linked list. So let us run this program and see that whatever we have done is correct or not. So in the last class, we already have added A, B, C, and then D, E, F, and then G, H, I to the linked list. So what was our current situation of our linked list? The current situation of our linked list was we had A, and then we had B, then we had C. These were our three nodes. After ABC, we had D. D was another node. Then we had E. Then we had F. So these were our six nodes, and D, E, and F were appended at the end of the linked list. So this was connected to this one, this was connected to this one, and this was connected to this one. Now, G, H, I was added at the beginning of the linked list. So G will come here, and G will be connected to A like this. Then H will come here, and it will be connected to G like this. And I will come here, and I will be connected to H like this. So this is our whole linked list. So the final status of the linked list after all these statements will be, first we will have I, then we will have H, then G, A, B, C, D, E, and F. So this will be our whole linked list situation. Now that we have formed the linked list, we will start deleting nodes from the linked list. And so as to delete nodes from the linked list, we have already written a function that deletes a node from the start of the linked list or from the beginning of a linked list. So as to do that, let us call that function. So the name of the function is delbeg. So I'm just going to call that function once. So I'm going to write here del beg. It requires no argument, so I'm just going to leave it empty. And after deleting a node, I'm going to display the current status of the node. And then again, I'm going to delete another node and then going to display the current status of the node. So I have deleted two nodes from the beginning of the linked list. So when I have deleted two nodes, I will be deleted and H will be deleted. So this display is going to give us H, G, A, B, C, D, E, F. And this display is going to give us G, A, B, C, D, E, F. So this will be our final status of the linked list. So let's hope for the best. So once we have written this program and we have made changes in the program, the first thing that we should do is that to compile this program. And we know to compile a C program, we have to write gcc linked underscore list dot c minus o ab.exe. I could name it anything.exe, it doesn't matter. So after writing this program, after compiling the program, I'm just going to press enter. So this statement gave us no error. That means my program was successfully compiled. If my program was successfully compiled, that means there is no error in the program. Once we are done with this, so let us run this program. And so as to run this program, we have to call the exe file, and the exe file is ab.exe. So run this program, and we can see here we have added this many nodes to the linked list. So this node is deleted. At first I is deleted, so H, G, A, B, C, D, E, F. Then after I, H is deleted, so the final status of the list is G, A, B, C, D, E, F. So this is our final situation. So the function to delete a node from the beginning of the linked list was successful. So our next target would be to write a function that is going to delete a node from the end of the linked list. So let us see how we can actually do that thing. So like before, we are going to discuss the strategy first. Once we have our strategy on point, we are going to implement it using C. So let me make my linked list. Okay, I have made my linked list. So the what we have to do, we have to delete this particular node because this is the last node in our linked list. So what should be our strategy? This is the start. This contains the memory address of the first element of the linked list. Then all the other nodes contained the memory address of the next node in the linked list. Now, so as to delete the last node, what we have to do? We have to point the second last node towards null. We have to point the second last node towards null, and then we have to delete this particular node. So as a result, the last node will be deleted. Now, so as to point the second last node towards null, we have to know the memory address of the second last node. And what do we understand, or what is the property of the second last node? So let us see. The last node is pointing towards null. The property of the last node is that it points towards null. The property of the second last node will be if X is the memory address of the second last node, then next will be the last node, and last node is going to point towards null. So what is the property of the second last node? The property of the second last node is that it is going to, the next of next is going to be null. So this is our second last node. This is our last node, and this is null. So we have to traverse through the linked list and we have to find the node which satisfies this particular condition. So let us start with writing the function. Let us name this function as del beg. It should, yes, it should be del end. So void del underscore end. And as we know, we are deleting a node, so we require no particular argument, or this function does not have to return anything. The only functionality of this function is to delete a particular node from the linked list. Now, what we are going to do is that we are going to take a temporary variable and store the value of the start in this temporary variable. Now, why do we always store the value of start in a temporary variable? So if you look through the whole functions that we have written in the previous cases, we are using the value for start, or we are using the value for header to traverse through the length of the linked list, and we are like updating the value of cur step by step. So if we had used the value of start, we would have destroyed the value of start, and as a result of this, when the next time when we are dealing with the linked list, it won't give us our desired result. So it is very necessary that you store the value of start in some safe variable, that in this case is temp. So what do we know is that if the value for temp is equal to null, that means temp is pointing towards null, and that in return means start is pointing towards null. And if start is pointing towards null, it means that our linked list is empty. So what we are going to print? We are going to print printf linked list is empty. That means we cannot delete an element in this particular situation. Now that we are done with this empty linked list situation, let us go to the else part. In the else part, we are dealing with a non-empty linked list. And what do we know? We know that we have to find the second last element of the linked list. And the property of the second last element is while cur. Cur is the variable, oh sorry, temp is the variable that is keeping track of the current node. And if that current node next, if the next of that current node, next of that current node points towards null, that means we have reached our second last node. That means we are going to run this loop until and unless we reach to the second last node. So I'm, as a comment, I'm giving it here is that this loop executes until we reach the second last node. So as to like traverse through this node, we have to again write temp equal to temp next. So when we come out of this loop, we are sure that we have the memory address of the second last node. And when we have the memory address of the second last node, what should we do? If we have the memory address of the second last node, the second last node should point towards null. What it should do? The second last node should point towards null, and this have to be deleted. So now let us take another variable. Let us name it as node cur equal to temp. Temp next is equal to null, and then we are going to free cur. So let's take it for a dry run. So after this particular loop is being iterated or executed, the value of temp would be 200. The value of temp would be 200. Now, this value of 200 is stored in another variable called cur. So the value of cur will also be 200. So now let's see, we have done a mistake here. uh, we want to store the value for 300 in cur because we want to delete this value for 300. So instead of writing node star cur equal to temp, we should write node star cur is equal to temp next. Fine. So now instead of storing the value for 200 here, now cur has the value for 300. The value of cur is 300. Now the value of cur is 300. Now temp next is equal to null. So temp is 200. So instead of pointing it to 300, this is going to point towards null now. If this is pointing towards null, this is going to point to this one, and this connection will be disconnected. So this will be disconnected. So this last node, or the node that is present in the 300 memory address, will become an orphan node because nobody is pointing towards this node. So I'm writing flicker that is going to delete this particular orphan node, that is going to delete this particular orphan node. So as a result of this particular function, we are able to delete a node from the end of the linked list. So once I have written this program, let us take it for a test run. So what is our current situation of our linked list? We have inserted here 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 nodes in the linked list. But after inserting 9 nodes in the linked list, we have deleted another 2 nodes from the linked list. So let us first draw the linked list. We have A, and after A, we have B, and after B, we have C. And then after C, we have added 3 more nodes, one after another. So after C, we will have D, and after D, we will have E. After E, we will have F. Now we have added GHI at the beginning of the linked list. So G will be in front of A, H will be in front of G, and I will be in front of H. So this is our final scenario of our linked list. So if we write it in a list format, I will come first, then H, then G, then A, then B, then C, then D, then E, and then F. So this is the current situation or the current scenario of our linked list. So when we call this del beg function, it is going to delete this initial node, and then it is going to delete this node. So the final status of the linked list will become G, H, B, C, D, E, and F. This will be our final scenario. So these 2 nodes will be deleted. So now we have written the function to delete nodes from the beginning of the linked list, and then we have written function to delete nodes from the end of the linked list. So now we are going to call those functions. I'm going to write del end, And then after calling this function, I'm calling the display function and another del end, and after this one I'm calling the display function. So if I look into this scenario right now, so this was the current scenario of our linked list. So we have called del end once, so this is going to delete this node, and this is going to delete this node. So after the last two nodes are deleted, we are left with G, and then A, then B, then C, then E. It should be our final result. So let us write the final result here. G, A, B, C, D. This is the final result after all these operations are performed. I'm going to clear the screen in this part, and then we are going to execute this function. I have cleared the left hand side of the screen. So now I'm ready to compile this function and execute this program. So we know to compile this function, we have to write this particular statement gcc linked underscore list dot c minus o av.exe. So now I'm going to press enter. So that gave us no error. That means our program was error free and it was successfully compiled. Once the program was successfully compiled, let us call the executable file, that is av.exe. So let us run this once and we can see that the final result is G, A, B, C, D, and that is what we have assumed, or that is what we wanted. So I hope all these elementary functions of linked list were clear to you. Let us revise, or let us just rewind whatever we have learned. So let me clear the screen so that I can make a mind map of whatever we have learned. At first, we have learned representation of linked list. So I'm just going to write LL as a short form here. And then after we have learned the representation of linked list, we have learned to form a simple skeletal structure of a linked list, structure of LL, then function to display all the nodes that are present in a linked list, display all the nodes that are present in the linked list. Then we have learned about appending a node at the end of the linked list. Then we have learned about adding an element at the beginning of the linked list. So add, beg, and after all this, we have learned code to delete an element, delete from the beginning, and after deletion, we have learned delete from the end. So these are your elementary functions regarding your linked list. I would encourage you to practice all those elementary functions because these are very necessary when you sit for your interview or for any coding examinations that you're going to have. So now that we are done with this, let us try to write another elementary function of linked list, that is to reverse a linked list. So let us first understand what is our strategy, and now what is the strategy we have to follow so as to reverse a linked list. So let me first make a linked list for you. And once I have made that linked list for you, I'm going to discuss how we are going to write a program that is going to reverse that particular linked list. So let me just draw that particular linked list. So I have drawn my linked list. So our target of this particular reverse list function would be to make C as our initial node B as the second node, A as the last node, and A should point towards null. So this is what we mean when we say that we are trying to reverse a linked list. So first, let me just write this function, and I'm going to take you step by step what is happening throughout this function. So we require a lot of temporary variables in this particular function. So the first temporary variable we require is start, and then we require pref, and we are going to initialize it to null, and then we require another variable called spref, and we are also going to initialize it to null. Fine. So instead of writing it in a single line, I would prefer that if you could write it in separate lines, that makes us easier to read the variable names and easier to work with all these variables. So this is node start pref. Okay. So we have initialized all our temporary variables that we are going to require all throughout this function. Our first situation, or the first situation in which we actually cannot do anything, is the situation in which the linked list is empty. So I'm going to write here if cur, or instead of cur we can just write start is equal to null, then I can say that printf linked list is empty. Now there is another thing that I would like to add in this particular situation is that if the linked list is empty, then these temporary variables that we already have defined have no use. So this is just going to take up some free memory that we are not going to use in this function. So I'm just going to delete them and write them in the else part. It means that I'm going to initialize the temporary variables only when I'm sure that your linked list is not empty and we can actually reverse the linked list, not before that. So when I'm sure that linked list is not empty, I have initialized my temporary variables. So once I have initialized my temporary variables, I'm just going to write a loop in which I'm going to write cur not equal to null. That means this loop is going to run until and unless the current value of the cur is not equal to null. Then I'm going to write spref equal to pref. I'm going to come to its dry run and pref equal to cur, and cur equal to cur next, cur next, and pref next equal to spref. Fine. And after that we are going to write start equal to pref. So this was everything. So now just take this function for a dry run and check we can actually reverse our linked list or not. So another thing that I would like to add in this diagram is the direction of your linkage. So this link is here and this link is here. As because we are reversing it, the direction of the linkage is going to change. So I want to specifically mention the direction of the linkage. Now the value of cur is start. So I'm just going to make a note here that our cur is 100 because the value for start is 100. Then value of pref is null, and value for spref is also null. We have defined three temporary variables. So this particular loop is going to execute, or this particular loop is going to iterate until and unless the value of cur is not null. Then we are writing sprev equal to prev. So value of sprev is going to become prev. So this is also going to become null. Prev is going to become cur. So prev is going to become 100. Cur is going to become cur next. So cur next is 200. This will become 200. And prev next, the next of, like, the next of prev, that was your 100, is going to become null. So instead of this thing here, when 100 is not going to point towards this thing now, this is going to point towards null. Prev next is going to become sprev. So prev is 100. So the next part of 100 is going to point towards null. So one iteration of the loop is complete. The value of cur is 200. We are currently at this particular scenario. So this is the value for cur. Prev is equal to 100. So prev is here, and sprev is like null only. So now let us take this function for another iteration. Sprev equal to prev. Sprev is equal to prev. So value for sprev is going to become 100. So this will become 100. Prev is equal to cur. So the value for prev is going to become 200. And cur is going to become cur next. So value for 200 is going to become 300. Fine. Now prev next is going to become sprev. Prev next is going to become sprev. So 300, instead of 300 here, this 300, and this node is going to point towards this node, and the direction of linkage will be reversed like this. So we can actually see that we are in the process of reversing this linked list. So now the value for cur is not yet null. So we are going to go for another iteration. Sprev is equal to prev. So value for sprev will become 200. Prev equal to cur. So this will become 300. And cur will become cur next. So this will become your null. Now prev next is equal to sprev. Prev next is equal to sprev. So instead of pointing towards null, this is going to point towards 200. And this linkage will be reversed. So I'm just going to delete this one, and I'm going to make another linkage, and I will change the direction of it. So we have successfully reversed this one. So our first node is pointing towards null now. Second node is pointing towards the first node, and the last node is pointing towards the second node. So now when we try to iterate through this loop again, we can see the value for cur is null right now. So we are going to come out of this loop, and outside the loop we have written start equal to prev. So what is the value for prev here? The value for prev is 300. So instead of 100, the value for start is going to become 300. So I'm going to write here 300, and this 300 is going to point towards this node, and this will be your start. Fine. So this is your scenario of your linked list. So now let us run this program and see that we have done this correctly or not. So again, we have already written all these statements. So what do we know? So let me just erase whatever we don't need. We don't need this part. So what is the current scenario of our linked list? We had A, we had B, we had C, then we had D, we had E, then we have F, then in front of this one we had G, then we have H, then we had I, and when we executed or invoked two these two functions, we have deleted this one, we have deleted this one, and when we executed these two functions, we deleted this one and deleted this one. So the current scenario of our linked list is G, A, B, C, D. So now if we call our function reverse list, so this should give us D, then C, then B, then A, then G. So this should be our final status of the linked list. This is your final status. Final status of our linked list. So let us first execute this function and see that we have reached our goal or not. Because theoretically, after dry run, we have seen that we could actually reverse a linked list. So the name of the function is reverse list. I'm just going to invoke this function here, reverse list. And after invoking this function, I'm going to call the display function so that we can actually see the reversed linked list. So our output should be DCBAG. So I'm just going to write our output here, DCBAG, and I'm going to erase this rest of the stuff so we can see our actual output correctly. So I'm just going to add another line before this reverse list here, printf the reversed list is, and then I'm going to print the reverse list. So I will first compile this function, and compilation was successful. We didn't get any error. And once the compilation was successful, I'm just going to call the .executable file. And when I press enter, I can see that the current status of the linked list was G, A, B, C, and D, and after we have reversed our linked list, the status has become G, A, B, C, D. This is the final status of the linked list after we have successfully reversed our linked list. So this was your another elementary function that we can do in linked list. There are other non-elementary function, or I can say there are other many other functions that you can actually do in linked list. But those functions can all derive from the elementary functions that you have learned in these two classes. So I hope that whatever we have learned in linked list chapter and whatever little competitive program that we did in the like previous previous to previous class, I hope that actually helps you to crack TCS NQT. But don't worry about this now. First May is going to be an aptitude and verbal ability and logical ability test. So in short, I can say that in first May, you will have your cognitive test in which you will be tested on aptitude, you will be tested on logical, and you will be tested on your verbal ability. Once we are done with this, I will be back again with few more coding sessions where we are going to discuss more competitive coding programs. We are going to look into more problems and stuffs, and we are going to solve more programs to help you prepare for the next segment as well. In the next segment, that is after 1st May, we are also going to discuss some important programming logical questions and like important OOP concept, DBMS concept, SQL concept, and pseudocode and output and input questions that are there in your TCS NQT syllabus. But for the next 1 week, till your aptitude examination, we are going to concentrate on aptitude, logical, and verbal ability only. I hope you found today's lesson interesting and you could understand, or I was able to teach you properly. If you had any doubts, or if you think that if there was any problem in today's lecture, you're always free to drop a comment in the comment section below. You can also join our Telegram channel. I will put the link of our Telegram channel in the description box below and in the comment box also. You can also join our Facebook page, and you can join our Instagram for more updates. You can log into www.campusprep.com, where I have organized all the materials that is going to help you to revise to crack TCS NQT. Thank you for joining us today. Have a nice day ahead. Thank you. Bye bye.